Good evening, sir.
Good evening, Varun.
Sir, what are you doing today?
Good evening, Varun.
Sir,
Yeah, good evening.
sir, what are we doing today?
Uh, we are revising the chapter atoms and molecules or force.
Okay, sir.
We're revising. Just give 2 minutes till everyone's right. I think someone is taking late. So just in 2 minutes we'll be starting.
Okay, sir.
Until then, if you have any doubts, you can ask. You have any doubts from any topic?
No, sir. Sir, but I have small doubt from fourth chapter, sir,
Hmm.
chemistry, structure of atom.
Okay, all right. So what's your doubt?
Sir, what is a valence electron, sir? I didn't understand the topic.
What is
Valence electron.
valence electron?
Yes, sir.
Okay. So valence electron is the number of electrons present in the outermost shell of an atom. For example,
So the electrons
if-
present in the N shell.
yeah, N shell, the outermost shell, they are called as the valence electron. And you have another term as valency. So don't confuse between the two, valence electron and valency.
Sir, valence and valence electrons are both not same.
Valence electron is the number of electrons present in the outermost shell that we call as the valence, and valency is the combining capacity of an atom.
Okay, sir.
Combining capacity, like how many electrons are required to complete its octet, or how many electrons will the atom donate. Okay.
Okay, sir.
Okay. Anything else? So for example, if you say for carbon, so carbon has, or let's take the example of oxygen. So oxygen has a total of 8 electrons, and if we write its configuration, so it has 6 electrons in the outermost shell. Okay, so valence electrons for oxygen would be 6. Got it? And what will be the valency of oxygen? What would be the valency of oxygen, Varun?
Yes, sir.
No. Valency would be 2. Oxygen requires 2 electrons to complete its octet. Okay.
Okay, sir.
So valency for oxygen is 2, but valence electron is 6. Got it? Pranav?
Okay, sir.
Pranav? 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 Good evening, everyone.
Good evening, sir.
Give me one. Arun? Rachit? Rachit?
Yes, sir.
Okay, am I audible?
Yes.
Okay, so Rachit, let's continue now. Rachit, do you know the difference between valency and valence electron?
Yes, sir. Sir, valence electrons are the electrons that are present in the last shell of an atom, and valency is the combining capacity of an atom.
All right. So got it, Varun?
Yes, sir.
Okay, so Rachit, if chlorine has 17 electrons, a total of 17 electrons, so what
Yes.
will be the valence electron for chlorine and what will be its valency?
I'll have to calculate it.
Okay, so calculate it. For 17, everyone, find out for chlorine, atomic number 17. Okay, you have to find the total number, you have to find the valence electron and the valency for chlorine. So let's see how many of you can. So we have chlorine, atomic number 17. First, we'll write its configuration.
Sir,
So
valency is
configuration,
-1.
Sir, valence electron is 7.
valence
Sir,
electron is
valence
7. Very
electron
good.
and
So
sir,
we'll write
valency
7,
is -1.
287. So its valence electron is 7. Got it, Varun?
Yes, sir.
Okay, next we find the valency. So valency is the number of electrons or the combining capacity. So this chlorine in the outermost shell, it has 7 electrons. Now see how do we find the valency?
Sir.
Yes. So valency is if suppose an atom has 7 electrons or whatever number of electrons, so we observe that the outermost shell should have 8 electrons. Okay. Outermost shell can have 8 electrons as 8 is the stable configuration. It was observed that the atoms have the 8 as the stable configuration. So now for this chlorine to have 8 electrons in the outermost shell, it requires one more electron. So it is 1. Valency of chlorine is 1. Similarly, we obtained for sodium. So sodium has atomic number 11. Find out its valence electron and valency.
Sir, valence electron is 3.
Valence electron is
Sir, 1, sir, sorry, 1.
1. So again you write KLM. So it is 2, 8 and 1.
Sir, valency is 3.
So valence electron for this is 1. And what will be the valency?
Sir, 3.
3. No, valency will also be 1. Okay. To complete 8 electrons in the outermost shell. So currently M shell is the outermost shell here. And to complete the octet, it requires 7 more electrons in the M shell. Okay. It requires 7 more electrons for the M shell. So therefore, the M shell should gain 7 electrons. Now, it's not possible for an atom to gain 7 electrons. Why? Because the nucleus is about to hold it. Okay. The nucleus cannot hold 7 more electrons. And therefore,
So it will donate the 1 electron it has.
yeah. So it will remove the 1 electron. It will remove this 1 electron from here. And in that case, when 1 electron is removed, the M shell will become vacant. Alright.
Okay, sir.
So this M will be vacant. And now, so when this electron is removed, this shell will be vacant and L shell will be the outermost shell now. Got it? So L shell will be the
Yes, sir.
outermost shell and you can see that the L shell has 8 electrons. So therefore, valency of sodium is 1 and valence electron is 1. Similarly, you can think for these two also, magnesium and aluminium. So for magnesium, what is the valence electron for magnesium?
So 2.
Very good. Valence electron for magnesium is 2 and it has the configuration 282. Now what will be the valency? Niharika, what will be the valency?
So it will also be 2, right, sir?
Valency is also 2. Alright, it will be giving out these 2 electrons. For aluminium, it's 13. Okay, so it is 283. And it will have valence electron as 3 and valency as 3. Can you tell me what will be this for phosphorus? Atomic number 15. Nitrogen, atomic number 7. Try out for these two.
So for phosphorus, valence electron is 5. Sir, and valency is so 31.
The valency is 31. How much is valency?
Sir, is it 31?
No. How 31? You write it, it is 285. Okay. Shravan?
Sir, it is 3.
Shravan?
Yes, sir.
Okay, what is the valence electron for phosphorus?
5.
5. And what is the valency? Yes, Shravan, what is the valency?
1 second.
Sir, is it 3?
3. Okay, how we get 3? The outermost shell, it should have 8 electrons. Now for this to have 8 electrons, you just need to gain 3 more electrons. So it will be gaining 3 electrons, and hence it will have valency to be equal to 3 and valence electrons to be 5. So when the valence electron is greater than 4, then the atom is in a situation to gain electrons. When the valence electron is less than 4, in that situation the atom loses the electron. It's easy for the atom to lose the electron. Got it? So I can find out for nitrogen. Someone tell the valence electron and valency for nitrogen.
So 2, 5.
2, 5, that is the configuration. Very good.
Yeah.
What is the valence electron?
5.
How much?
5.
5. And what is the valency?
3.
3. Very good. So now I think everyone can find out the valence electron and the valency. Is there anyone who still finds out difficulty with finding the valence electron and the valency? Okay.
No, sir.
So I think everyone is clear with the concept of the valence electrons and the valency. Now, since we have started with the valence electron and valencies, we will also do the valence electron and the valency of ions. Let's see the ions here. So what are ions?
Sir, positively or negatively charged atoms.
Okay. So an atom or a group of an atom or a group of atom that is charged, which has a charge. Which is a charge on it is called as an ion. So we have two groups of ions here. One of the groups is called as the cation, and another group we have as the anion. So what are cations?
Sir, they're positively charged atoms.
Okay, the positively charged atoms or groups of atoms.
And then anion is negatively charged.
Okay, very good. The cations, they are positively charged species, and anions, they are negatively charged species. So we'll see some examples of the cations and anions. All right. We'll see some examples for this. So let's see some of the cations over here. So first of all, you see the cations, they are the groups of positively charged species, and if it can be either an atom or a group of atom. Okay. So cations, let's see first the atoms which are positively charged. So I'm placing them in groups of 3. Why I'm placing them in groups of 3? As they can have a charge of +1, +2 or +3. Okay, so hence I have created a group of 3. The first group will be the ones which have a charge of +1. The second group will be the one which has a charge of +2, and the third one will be the group which has a charge of +3. Okay, now the atoms or the groups of atom which have the charge of +1, it is a sodium ion, Na plus, there is a charge of +1. Potassium ion which has a charge of +1. Hydrogen ion also has a charge of +1. Okay, so these were the single atoms which have a charge of +1. Apart from them, you have groups of atoms also which have a charge of +1. For example, the ammonium ion, NH4 plus. This is the ammonium ion which has a charge of +1. Sodium ion, potassium ion, hydrogen ion, ammonium ion. Right? All these have a charge of +1. When we come across some other, we'll list them also. Is there anything else which has a charge of +1 apart from the ones which we have listed? Somewhere you'll find copper, Cu +1. So this is generally copper 1. Copper exists in two forms.
So
So this is
copper,
copper exists in two forms, copper 1 and copper 2.
okay,
Okay, so copper will be here in +1 group also as well as in the +2 group also. It is the one which shows a variable valence. This is generally called as cuprous. Alright. Now, for the cations having the charges +2, they are calcium, Ca2 plus, magnesium, Mg2 plus, barium, Ba2 plus, and okay. So for the cation, you have one more. I just remember that's silver, Ag plus. Then you can have your calcium, magnesium, barium. Can you think? Okay, iron, Fe2 plus. So this we call iron 2. Fe2 plus. These are the some of the cations which have +2 charge. Lead. Pb is the symbol for lead. So Pb2 plus, it also has the valency of +2. Now cations having the valency +3. They are iron, Fe3 plus. So we call it as iron 3. Then aluminium, Al3 plus. So these are the cations which we have. Cations with charge of +1, cations with charge of +2, the cations with charge of +3. Just have a quick look at them. Then we'll move to the anions. Shravan, Rachit.
Yes, sir.
Okay. So Shravan, just have a look. I'll be asking some of them.
Okay, sir.
You should be able to remember like what is the charge of that cation. For example, if I say magnesium ion, so you should know that magnesium has charge of +2. How many of you got magnesium having charge as +2? Okay. Now we'll move to the anions. So similarly, anions are also classified under the 3 ways, either monovalent, divalent, or trivalent. Monovalent means the one which have a charge of -1. Divalent means 2, and tri means 3. So we can also call cations to be monovalent, divalent, and trivalent. So see, next week we put here the list of anions. Okay, so these are anions which have a charge of -1, -2, and -3. Okay. So see, anions having a charge of -1, So there has been one doubt. All right.
Yes, sir. Can you please explain it if it's possible?
Okay, I'll just explain this. Okay, so we'll just see the anions and then I'll come to the doubt. So for the anions, the one with a negative one, they are fluoride, chloride, bromide, and iodide. Okay, so the names are, you must remember their names. This is fluoride. This one is chloride. Then you have bromide. You have iodide. Got it? All the names? Fluoride, chloride, bromide, iodide. They are the anions with a charge of -1. So it doesn't mean that they are the only ones. There are some others also.
Sir,
I'm still adding to
hydroxide.
the list. Okay, so for example,
Sir,
hydride.
hydroxide.
Hydroxide is there. We have hydride also. Okay. So hydride is hydrogen. Hydrogen can form a cation as well as anion. So Niharika, can you tell how can hydrogen form a cation as well as an anion? Niharika,
Yes, sir. So
can you explain?
it can exist in two different forms. Like
Hmm?
there could be two forms of hydride, or when they combine, when the two atoms
How,
of
but how it's possible that hydrogen can form a positive ion as well as a negative ion?
sir, because when they combine the two hydrogens, each hydrogen can be like different.
You see, it's because of the structure of hydrogen. Okay, see, if we come here again, if we make this valence chart for hydrogen, hydrogen has just one electron, so which occupies the K shell. Okay, the K shell of the hydrogen has just one electron. There are no other shells for hydrogen. Okay, also the K shell has a maximum capacity of 2. Right? What is the capacity of the K shell? 2. Okay, so this hydrogen can have both the things. It can either gain one electron to fulfill its capacity, or it can even lose the given whatever electron it has to attain the stability. Okay, so when hydrogen loses this electron, if suppose this electron is lost, then it will form H plus, and if it gains one more electron to form here valence as 2, then it forms a hydride ion. So hydrogen can form a cation as well as an anion. Got it? Okay. So hydrogen can form a hydrogen ion also or a hydride ion also. Now we have the hydroxide ion, OH minus. This is hydroxide. Then you have hydrogen carbonate, HCO3, also having the charge of -1. You have nitrate ion, NO3. Nitrate ion also have the charge of -1. It is also monovalent. You have right. Then from the negative 2 or the divalent anions, you have oxide, O minus 2, which is called as oxide. Then you have sulfide. This all we are getting from the valencies. Okay, so sulfur, sulfide, -2. You can check that the sulfur has a valency of -2. And that is why the sulfur over here, it forms an anion as a divalent anion. Okay, so this is not sulfur, this is sulfide. Sorry. We'll be writing it as sulfide ion. Oxide, sulfide. Then it will also form carbonate, CO3 -2. Remember that carbonate is a divalent anion, whereas a hydrogen carbonate is monovalent. Then you have sulfate, SO4 2 minus. So this is a sulfate ion. Okay. So if you remember anything else, we'll just add up the list over here. Then for the ones having the charge as -3, they are trivalent. So for the trivalents, you have nitride, which has the valency of N-3, phosphide, which has P-3. Then you have phosphate group. So phosphate group, it's PO4 whole thrice -3. All right. So these are some of the anions which we have listed over here. You are supposed to remember their names and their symbols along with their valencies. Okay. Now, why do we need this? Why are we supposed to know all this? To be able to find out the formula of a compound. Using this, we can find out the formula of a compound. Let's see how. Suppose I want to make the formula for calcium oxide. Calcium oxide. I want to form the formula for magnesium oxide. I want barium chloride. Okay. You have iron 2 sulfate. Okay. Make these formulas. Everyone start making. I want all of you to make these formulas. Copper sulfate.
I cry.
Can you make the formulas? How many of you can make the formula for it? Just raise your hands so that I know, yes, you are okay. Yukta can make all the formulas. Nihari can. Okay. Or two people have raised, so two people can make the formula. Okay, right. Try it out. Shravan? Shravan?
Yes, sir.
Okay, try to make. I'll help you with it. Just try it.
Okay, sir.
Try to make these formulas. Good evening. How many of you have made these formulas? Harshit?
Sir, I'm
Sir,
done.
I'm done.
Done. Okay, well, very good. So silver chloride, try out these also, silver chloride and silver bromide. Is silver chloride, silver bromide, aluminium nitrate. You have copper chloride, Pranav, Pranav, are you there? Pranav,
Sir,
Pranav, you are not audible. Okay, see, I'll make up all the formulas. Let's try each one. So those who have made, that's very good. You just keep a check, and finally you will tell how many of them. Yes,
So one doubt. In
okay.
copper chloride, which one?
Two, copper 2.
Okay, sir.
It's copper 2. Okay, so this is copper 2. So calcium oxide. For the calcium oxide, we know here, we'll first write down their valency. So we'll write here copper, we'll write oxygen. So copper has valency 2, oxide has a valency of 2. So these are plus 2 and minus 2, that's the thing. You just cross these valencies like this. So your formula should be Ca, it would be Ca, since both are 2 and 2, so you get Ca2O2, which means that for 2 calcium atoms, there are 2 oxygen atoms, which is the same as the ratio still holds even if we write down CaO, which means 1 calcium for 1 oxygen atom. Okay, so the formula for calcium oxide would be CaO. Okay, formula for magnesium oxide would be MgO. The formula for barium chloride, barium has the valency of plus 2, chloride has the valency of minus 1. So if you find for barium chloride, it will be BaCl2. Iron sulfate. Rachit, did you get the answer for iron sulfate?
No, sir, mine was wrong.
For
The
iron sulfate.
correct.
Iron sulfate, it's iron 2. So iron should have valency of 2. And sulfate also has a valency of 2. So you get FeSO4. You should be adding 2, 2, then cancel those 2, 2, as the ratio still holds as 1:1. So it is FeSO4. Then copper sulfate, it's CuSO4. Silver chloride, silver is Ag, and it has a valency of plus 1, chloride has a valency minus 1. So AgCl. Silver bromide, it will have the formula AgBr. Aluminium nitrate, so aluminium has the valency 3 and nitrate has the valency 1. So it will be AlNO3 all thrice. Aluminium nitrate. See, this 3 is for all the nitrate, as the nitrate overall has the valency of minus 1. So 3 nitrate atoms are required. 3 nitrate molecules are required. Sir.
Sir, how is aluminium nitrate AlNO3 whole 3?
Mm. Mm.
Sir,
नहीं नहीं बोलूंगा, ठीक है, ओके, या युक्ता, हाँ सर,
Sir, how is aluminium nitrate AlNO3?
हम्म, हम्म, चलिए ठीक है सर, थोड़ा क्लास ले रहा हूँ मैं। So Yukta, what do you say?
So I was asking that how is aluminium nitrate AlNO3?
Okay, so aluminium, you have the valency for aluminium as 3. Nitrate, the whole NO3, it has the valency 1, which is -1. So you can just cross it. You will get aluminium here as 1, and nitrate overall NO3 is nitrate, and you should get 3 for this. So 3 is for whole nitrate, you write whole 3. We don't write 1, so the formula is AlNO3, whole thrice.
Okay, sir.
For copper chloride, it's CuCl3.
CuCl2.
Okay. For sodium chloride,
Sir, NaCl.
NaCl. All right. For sodium chloride, it's NaCl. Got it?
Sir, can you please explain my doubt, sir, if possible?
Yeah, now we can explain your doubt. Just 1 minute. Let's check up the doubt now. Mhm. All right. Okay, see this one. So the question is, element X has a valency of 2 and element Y has a valency of 3. What are the correct formula for their oxides? So just when you are not getting it, read the question 2 times, 3 times, you'll get the answer. You see, the element X, so we write here the element X, its valency is 2, we write here 2. Then we want to find out valency of its oxide. So we write here O, and oxide has a valency 2. Okay, so it will be, the ratio comes out to be X2O2. And since the ratios is same, you can cancel the ratios and it will be the same equivalent to XO. Okay. For the element Y, we make the, yes?
Sir, in English term, like the X2O2, how did you cancel that 2?
No, it's not. Okay, you have to remove that too. The ratio is 1:1. So whenever the ratio turns out to be 1:1, you remove them.
Okay, sir.
For Y and O, Y has a valency 3, oxide has a valency 2. So now you will get the formula as Y3O2. So this is the formula for the oxide of the second one. Is it clear now?
Okay, sir.
Okay. So you have X2O2 and Y3O2. X2O2 being changed to XO and the last one XO. So this is your doubt. Now anyone, everyone has cleared this, all the formulas? Here, sodium chloride is also called as the common salt that is used in our kitchen. We call it as the common salt. Okay. This one, copper sulfate, it is also called as with the name blue vitriol. It's blue in color. So another name for copper sulfate is blue vitriol due to its blue color. Got it? Silver chloride and silver bromide, they are the chemicals or they are the salts which are used in photography. So if you are asked which chemical is used in photography, it is silver bromide and silver chloride which are used in photography. Okay. Any doubt to anyone? So I hope today we have understood this concept of valence electron, valency. We have also understood the anions and cations. We have also understood how to form their formulas. Okay. The cation part in the formula, it is written first, and the anion part is written later. Okay. Now try to write down a few more. Try to write a few more, like ammonium hydroxide, calcium phosphate, favorite one. Try out these ones. Shravan,
Yes, sir.
how many of them have you done?
4.
4. Okay. And how many you got it correct?
Yes, sir. I got 4 correct. 4 correct.
4 correct. Okay. Good. So try out this ammonium hydroxide. Shravan, try out ammonium hydroxide. Everyone try out
Okay.
ammonium hydroxide. The formula for ammonium is NH4.
Sir, is it NH4OH?
Yeah, this one is, it turns out to be NH4OH. Calcium phosphate, Ca3PO4 whole twice. You must check the formula. Calcium phosphate is Ca3PO4 whole twice. Okay, you can check its formation. The phosphate has a valency of, okay, the phosphate has a valency of 3 minus 3, and calcium has a valency of 2. So you get the formula Ca3PO4. All right. Okay. So, all right. Thank you and happy learning to you all. Bye.
Thank you, sir.
Okay.
Thank you, sir.